This lab considers the interaction between encoders and motors to allow for precise movement of a cart. In the basic form, encoders are used to gather information about location and speed of a specific component. In this assignment, the encoder will act as an odometer, allowing the operator to decide how far and fast the cart will move. The H-bridge allows the code and circuit to send signals to multiple motors simultaneously. Therefore, the circuit will read the location and speed of the cart using the encoders and send the proper signals back to the controller to allow for the code to account for changes in the cart's movement. This is the cart chassis. The cart will hold the necessary circuit boards, wheels, motors, and encoders. Overall, the cart must carry all the proper components as it moves, allowing for no wires attached to an external source. This means that batteries must be used to power the robot. This is an encoder. It will be attached to the DC motors and wheels. As the wheel turns, the encoder wheel rotates. When one of the holes is aligned with the encoder will output a high digital signal. The Arduino will count each time a hole passes the encoder and convert this to distance. This is a double H bridge. This component is a motor controller that allows two motors to be operated in both directions. This is a key component to allow your motors to work simultaneously while still allowing for simple control of the motors. Without the H-bridge, a large number of diodes and transistors would be needed to control the motors. Due to the necessary controllers for the cart, this assignment will incorporate three main circuits, one being the Arduino board, then the H-bridge, and finally the breadboard. This is the cart that will hold all of your components. The first task to build this will be connecting the wheels and motor. These are the encoders. They will be attached to the motors and wheels in this location and connect to the proper circuits. This is the breadboard. The encoders will be attached here and here, allowing them to obtain power from the batteries while being controlled by the Arduino. The breadboard has two power buses, a 6-volt and a 5-volt that must share a ground. The motors and Arduino are powered by the 6-volt, and all control and encoder power are done with 5-volt. The circuit will then flow into the H-bridge to allow for proper motor control. The H-bridge will send the proper power to each motor. The power to each motor will be controlled by the Arduino. It has 4 outputs corresponding to 4 inputs. When an input is made high, the output is made high. Similarly, when the input is low, the output goes to the ground. Finally, the Arduino is connected to the breadboard and H-bridge. This will allow for overall control of the cart. Double is a new variable type. Double is used when decimal values are required. In this code, double variables are used to convert the fraction the robot has moved towards the goal location to a speed. Interrupts are used to make a function operate independently of the main loop. In this code, interrupts are used to update the distance moved every time the encoder value changes. These functions are called update left and update right. The interrupt function first asks for the interrupt number on the Arduino interrupt 0, correlates to pin 2, and interrupt 1 to pin 3. The second part is the function that the interrupt calls. In our code, update right and update left are called. The last part of the interrupt is to tell when to interrupt. In our code, it interrupts when pin 2 or 3 goes from a low to high value, or rises, which is why rising is used in the function. Volatile is a variable type used by Arduino to demonstrate that the variable could change between the times it is accessed. In this code, the position right and position left values that is volatile because it may update if the interrupts take place between access of the position values. Constrain is a function that defines the maximum and minimum values of a variable. Any values outside these constraints will be made either the maximum or minimum depending on its previous value. Constrain is used to keep the values of the speed left and speed right values to PWM values that are reasonable. The maximum and minimum values can be changed to allow the motor to go faster or slower. The variable section defines the Arduino pins corresponding to the pins of the motor control. These must be PWM pins. It also defines the position values read by the encoders. The last variable is a bias value that is used to adjust the motor speed, just in case one motor is inherently faster than the other. This section defines the motor pins as output pins and creates the interrupts. The interrupt occurs when the pin goes from low to high, which is why the interrupt says rising. This is where the code decides which functions are used. It is called the forward function, which tells the robot to go forward 25 inches. The break function tells the robot to wait 2,000 milliseconds or 2 seconds. Then the left function tells the robot to spin to the left 180 degrees. The last break function tells the robot to wait for 1 second. Then the loop starts over and the robot goes forward 25 inches, so on and so forth. This function first converts the degrees defined in the loop to position values for each encoder. Then it uses a while-in function to make the robot wheels go to these positions. Basically, until the position read by the encoder is equal to the called position, the robot will use the difference between the desired position and actual position to give the motor a proportional speed. This is done using the map function. This function works exactly like the left function, except the motors will spin the same direction. This function simply turns all the motor pins to low values, essentially turning off the motors. It will then delay however long it is told to do so. These are the interrupt functions. When one of the interrupts is activated, it will cause the corresponding function to occur. Each time this function happens, it will add 1 count to the position value.